Now, the last section that we're doing here, the reason that I broke it up across 2 days isn't because the content itself is going to take 2 days. I just really wanted to delve into a lot of these different type of problems. The overall concept that we're going to use for these isn't any different than what we did yesterday. So when we look at this first one here, and yes, there is this Smart Notebook basic version, this here at the bottom, because they gave us a licensure for the few months because we can only buy it at the beginning of the new year, which for the school year is in June. So we have to wait till June so we can officially buy the subscription. But they've been giving us free trials. They renewed it in January and it expired again. So working with them to get that fixed. Yep, because if we don't own the subscription to Smartboard, it puts it here. And it would go away if it was actually hooked up to an actual Smartboard, but it's not anymore, so it comes back up. But other than that, it's going to stay right there. So let's look at these here. Now this first one here, let's make sure, because today, let's check for our restrictions first, so that way we know when we get to the answer, if one of the restrictions shows up, that answer doesn't work. Now looking at the 3 places here, in the denominator we have an x plus 1, we have a 2x, and we have a 2x. So for x plus 1, what value of x would make x plus 1 0? Negative 1. So we know x cannot be. Now we do have 2x twice, so it's 0. What would make it 0 be the same for both of those there, which would be 0. So that means if we get a solution of negative 1 or 0, that one does not work. Okay, so now that we have the restrictions down, we can go on and start solving this here. Now at this point here, we need to multiply by a least common denominator. We need to multiply each one of these terms by something so that the denominators simplify out. So what will we need to multiply everything by? Yes, we'll need a 2x and an x plus 1. Even though 2x does appear in 2 different denominators, in each one the 2x only appears once, one time, so we only need it once. Because when we do this here, well, for the first one, the x plus 1 and x plus 1 will cancel. For our middle one, the 2x and 2x will cancel, and the last one, the 2x and 2x will cancel. And so what that leaves us with is the first one is going to be, well, 3 times 2x. And what is 3 times 2x? 6x minus times x plus 1 is equal to 3 times x plus 1. I went on and did the 3 times 2x because those are just 2 terms. Multiplying those together is not that bad. I would be a little bit hesitant on doing the negative 5 times x plus 1 because if we're not paying attention, we might not remember to take the negative with it, and it just to multiply both of them by 5. Now at this point here, we can distribute the negative 5, which will tell us that we have 6x minus 5x minus 5 is equal to, here we'll distribute the 3, 3x plus 3. Now looking at this here, what is the greatest exponent with any of the variables? 1. The exponents, because we're looking for exponents with variables. Well, we don't have any, so it's 1, yes? So that means we just need to get x by itself and solve. So we don't have to do a quadratic or anything getting it equal to 0. Because if we have a variable with a power greater than 1, so 2, 3, we need it all on one side and solve that way. But here, luckily, we only have x. So let's combine like terms. 6x minus 5x is x. Minus 5 is equal to 3x plus 3. Now where can we go from here? Well, we can go two different directions. Subtract x, which will tell us that negative 5 is equal to plus 3. Subtract 3. Which will tell us that 8 is equal to, and last but not least, we would divide by 2, telling us that x is equal to negative 4. So what did you get?
Oh, I got one. So I subtracted 5 from this.
That would work, but since this is negative 5 times our plus 1.
Oh, yeah.
Yep. Yeah. Because that's one of the reasons why I didn't go from this step here down to this step here, is it's very easy to lose a sign. Because dropping one negative is so easy to do. If I'm not paying attention, I will do it too. Now, we got x is equal to negative 4. Was that one of our two restrictions? No, because our restrictions were negative 1, I believe, and 0. So, negative 4 is the solution, and that works. Questions on this here? Let's look at this one here. 4x plus 1 divided by x plus 1 is equal to 12 over x squared minus 1 plus 3. Now, we're going to use the same exact process because we need to multiply each of the terms so that the denominator simplifies out. It is very tempting at this point here to multiply everything by x plus 1 and x squared minus 1, yes? Will x squared minus 1 factor? Is x squared and 1, are they perfect squares? Because x squared was x times x. 1 is 1 times 1, and they are being subtracted. So x squared minus 1 is the difference of perfect squares, yes? So let's factor it and see what happens, and see what we get in the denominator. Because for the 4x over x plus 1 will stay the same. 12 plus 3. So we need to factor the x squared minus 1 since it does factor. And if we factor this here, well, we would get x minus 1 and x plus 1. Now, if we'd multiplied everything through by the x squared minus 1, we would eventually get to the correct answer. But we would have added an extra factor of x plus 1 into each term, or at least into the other two. Because looking at all the denominators, how many times does x plus 1 appear? Two different places, but in each term it only appears in the two places it does. So if I'd have multiplied everything by the x squared minus 1, I'd have actually multiplied it with the x plus 1. I'd have added it in twice because it's inside that x squared minus 1. So whenever we come across these and we can factor the denominator, we need to, just to make sure we don't add an extra factor in. So here we don't need the x squared minus 1 to multiply. Essentially we do, but we just need to multiply by x plus 1 and Because if we'd have done the x squared minus 1 and x plus 1, we would have actually added another x plus 1 in there. And the downside to that is the degree of what we get after this step would have been 1 higher than what we would already have. Now, if we look at this multiplication here, well, for the first one, the x plus 1 and x plus 1 cancel out. In the middle, both of them, x minus 1, x minus 1, x plus 1, and x plus 1. And the last place we have neither of them. They both stay, yes? So let's write out what we have left. So in the first place, we have 4x plus 1 times x minus 1 is equal to 12 plus 3 times what? X plus 1 and x minus 1. Y'all might not like this because I think most of y'all already wrote that down, yes? Where did we get this from? We got it from the x squared minus 1, yes? I can put x plus 1, x minus 1, yes? But when we multiply them back together, we're getting back to what? If I don't have to do the step and it's already told it to me and I know where I got it from, might as well just put it back. Because if we can make it easier on ourselves, we should. All right, now we need to distribute, multiply. So for the first one here, we're going to multiply these two together. So we'll have 4x times x squared. 4x times negative 1 is 4x. 1 times x is going to be plus x. And 1 times negative 1 is negative 1 is equal to, well, 12 plus, distribute the 3. 3 times x squared is minus 3. Now, if we'd added that extra x plus 1 in, we wouldn't actually have a degree 2. The biggest exponent would actually have been a 3. We would have the cubic that we'd have to solve. It is still possible to solve it. We would just have to do a little bit more work to get to the answer. Now, looking at this here, we need to go on and combine like terms. And it would. 4x squared has no like terms over here, but the negative 4x plus x would be negative 3x minus 1 is equal to, well, the other side does have like terms of the 12 and negative 3, which would give us plus 9. Now we do have a quadratic, mainly because we see in 2 different spots we do have an x squared, yes? Let's move those onto the same side first. So at this point here we can subtract the 3x squared from both sides. 4x squared minus 3x squared will be minus 1 is equal to, well, these cancel, leaving us with 9. Then we can subtract the 9 from both sides, which will tell us that we have x squared minus 3x minus 10 is equal to 0. Do we want to factor this or solve it by factoring or the quadratic formula? Factoring, because I think y'all feel very comfortable at this point with factoring. So 2 sets of parentheses with our 3 spaces. Now since the third term, our 10 is negative, our signs would be opposite. So one would be positive, the other is going to be negative. Factors of x squared are x and x. Now the factors of 10, we have 1 and 10, 2 and 5. 2 and 5, which one's positive, which one's negative? 2 is positive and 5 would be negative. Now at this point here, we do have two things multiplied together that equal, so one of them must be 0. So either x plus 2 is 0, or x minus 5 is 0. So for x, we would subtract 2 from both sides, telling us x is equal to. And here we're going to add 5 to both sides, telling us x is equal to 5. So we have negative 2 and 5. And is either one of those one of our restrictions? Did we actually find the restrictions? Now, I do this every year. Because our two denominators really were x plus 1 and x minus 1. So it's plus or minus 1. Questions on this here? Okay, we'll definitely need to find the restrictions here. Do we know why? Solving an equation with, you kind of said it in the title. Okay. Now with this one here, we do have the x minus 3. In the middle we have x squared minus 9. And the last one we have x plus 3. Now I would not advise multiplying all of these by x minus 3, x plus 3, and x squared minus 9. Because let's go on and factor x squared minus 9. Because we'll need to multiply it because the scale at which the two ends, the one with x minus 3 and x plus 3, will be a little bit different than what we have in the middle. Now x squared minus 9 is a difference of perfect squares. X minus 3. Yes, x minus 3 and x plus 3. So if we'd have multiplied with x plus 3, x minus 3, and our x squared minus 9, we would have actually added two sets of extra factors, which most likely would mean taking it from a quadratic degree 3 all the way up to a degree 4, which would have made it a little more challenging to work. But before we delve into it, let's see what our restrictions are. Because for x minus 3 in both of those, we cannot have x being 3. And for the x plus 3, we can't have it being negative 3. Because if we have either one of those values, it will make one of the denominators 0. Okay. Now that we have that, I think most of y'all are already started with the multiplication. Because we'd be multiplying each term by x minus 3 and x plus 3. And if we do this here, in the first one, the x minus 3 and x minus 3 would cancel. While the middle, both of them will cancel. And the last one, the x plus 3 and x plus 3 would cancel. Which leaves us with 6 times x plus 3 is equal to 8x squared, because the middle term, the denominator is everything simplified out except for the 8x squared, minus 4x times x minus 3. Any questions on how we got to this point here? All right, at this point here, we can distribute the 6. 6 times x is going to be 6x, plus 6 times 3 is 18, is equal to 8x squared. So we do need to distribute the negative 4x. So negative 4x times x is going to be negative 4x squared, not 8. 4x squared, and negative 4x times negative 3 is going to be plus 12x. And again, we can go on and combine our like terms, so we'd have 6x plus 18 is equal to 4x squared plus 12x, because the 8x squared minus 4x squared would give us 4x squared. Any questions on this here? Now we do need to get this equal to 0. So the first thing we can do is, doesn't matter, we can subtract 6x or we can subtract 18. The order in which we do it doesn't matter. We just need to make sure we get both to the other side. If you wanted to, you could have actually written this all on one line, the minus 6x and minus 18, and done it all at once. This 12x minus 6x would give us 6x. And lastly, we'll subtract 18 from both sides, telling us that 0 is equal to 4x squared plus 6x minus 18. Any questions on how we got to this point here? Now at this point, we can factor it, solve it by factoring, or the quadratic formula. And I have a feeling y'all want to do this by factoring again, yes? Is there a greatest common factor? They're all divisible by? So we'll need to factor that out first, as we'll be left with 2x squared plus 3x minus 9. Now this will factor. Since our 9 is negative, the third term is negative, our signs are going to be opposite. One's going to be positive, one's going to be negative. Now the factors of x squared are our x and x. Now we need to figure out where we want to put the 2. Take a spot, Trey. Plus. Now the factors of 9 are 1 and 9, or 3 and 3. 3 and 3. Now if we check this here, 2x times negative 3 would be negative 6x. 3 times x is going to be plus 3x, which would give us a negative 3x. Is that what we wanted? We want it to be positive. We just need to flip the signs. So really, all you need to do is erase the plus sign to make it minus, and changing a negative to a minus sign to a plus is just drawing a line down. And this here would give us the correct answer, because it would change it to minus 3x plus, which would give us a positive 3x. Now we do have 2 or more things multiplied together to equal 0. I don't care about the 2 because the 2 does not have a variable with it, so there's no way that it actually make 2 be 0. The main ones we're focused on are the 2x minus 3 being 0 and the x plus 3 being 0. For the 2x minus 3, the first thing we could do is add 3 to both sides. These will cancel, telling me that 2x is equal to 3. And last but not least, we would divide by 2, telling me x is equal to 3 over 2. So there's one of our answers. For the other one, we would subtract 3 from both sides, telling us x is equal to -3. Exactly. This one here does not work because, again, we said x cannot equal 3 or -3. Since -3 matched up with one of those there, we can kind of cross it out. That is an extraneous solution. It is a solution that does come out, or we do find when solving it, but it does not work in the original problem. So -3 does not work. But we still have the solution of x is equal to 3/2. Because x equals 3/2 is not one of our restrictions, so it does work. We do have a solution. Now, if it had worked out that 3/2 was also one of the other restrictions, then it would be no solution because both of our solutions canceled out. Any other questions on this here? So what is the big change from having extraneous solutions, the one we just did, to the one we've done previous? We mark one out at the end. That's the only real change, isn't it? Nothing else changed. It just works out one of them doesn't work in the original problem. Let's look at the next one here. So we will need to find the restrictions most likely, but it'd be helpful if we factored the x squared minus 9 and the x squared minus 6x plus 9. Because if either one of those have common factors, we don't want to multiply it more than we need to for our least common denominator. Now x squared minus 9 will factor 2, x plus 3, and x minus 3. I think y'all are liking the difference of perfect squares more and more when we have to factor them because they work out very easily. Now x squared minus 6x plus 9, well, the plus tells me that the signs are the same and match the sign of the middle term, so we have negative and negative. Factors of x squared are 3 and 3. Because it works out that x squared minus 6x plus 9 is a perfect square trinomial, we get the same thing multiplied by itself. Well, now it's a little bit easier to look at the restrictions. Because in all the denominators, we have one or two things. It's either x plus 3 or x minus 3. So what will make x minus 3 0? Well, 3. And what makes x plus 3 0? Negative 3. And if we wanted to check and make sure we did get the correct zeros, it would just be setting each one of these equal to 0, x plus 3 is equal to 0, or x minus 3, and solving for the value of x. Now, what are we going to multiply each one of these by? X plus 3, x minus 3. X plus 3, x minus 3. X plus 3, x minus 3. Yes? So let's go on and simplify out. Now on the first one, the x plus 3 and x plus 3 would cancel, yes? X minus 3 and x minus 3 would cancel. When you get to the middle one, the x minus 3 would cancel with the x minus 3, and the do I still have one left over? Because how many x minus 3s do I have in the middle term? So how many do I need to multiply with? 2. Because I need x minus 2 to occur, x minus 3 to occur twice. because this is the first time we actually had it appear twice. So if any of the spots it occurs twice, we need it to occur twice. I just, yep, because we have to add it to all three. And that's also another good thing to be in the habit of not just going and crossing everything out, actually looking to see what's canceling. Because as we looked at it in the middle, okay, we had 1 and 1 canceled, but we still were missing another one we needed. And the last one we'll have x plus 3 and x plus 3 cancel. Now the denominators, as we see here, everything did simplify out, so we're good. And let's see what's left over. So the first spot we have 4x times our x minus 3 is equal to. In the middle one we have x minus 1 times plus times, we have x minus 3 times x minus 3, yes? Where did we get that from? Yeah, we can fill that back in. X squared minus 6x plus 9. Because that's where we actually got it, the x minus 3 and x minus 3 from, so we can put it back together to get our x squared minus 6x plus 9. Now at this point here, we do need to multiply through to use our distributive property. So 4x times x is our 4x squared. 4x times negative 3 is negative 12x is equal to. Here we have x times x is x squared. X times 3 is going to be plus 3x. Negative 1 times x is x, and negative 1 times 3 is plus. We have to multiply the 2. 2 times x squared is 2. 2 times negative 6x is negative. And 2 times 9 is plus. Now we do need to combine like terms on the right-hand side. Now we do have an x squared and 2x squared, and we can add those together to get 3x squared. So we have those two taken care of. Now our 3x minus x is 2x minus 12x is negative 10x, because we have 3 minus 1, which would give us a positive 2, and 2 minus 12 would give us a negative 10. And last but not least, we have negative 3 plus 18 is plus 15. Okay. Now we need to get everything on the same side of the equation. What can we do first? 3x squared? We can subtract the 3x squared from both sides. So we don't have a negative x squared, and that's a good thing to have, because having the biggest variable, the variable with the biggest exponent, staying positive is going to make it a little bit easier to work with. 4x squared minus 3x squared would be x squared. Now doing it the other way wouldn't be wrong. Because what we could do is, after we get it all done, we could factor that negative out to make it positive. Well, go on and add the 10x to both sides, which will tell us that x squared minus 2x is equal to 15. And last but not least, we would subtract the 15 from both sides, which tells us that x squared minus 2x minus 15 is equal to 0. Any questions on how we got to this here? Well, we can go on and solve this by factoring. Now, since the third term is negative, our signs are going to be opposite. We'll have positive and negative. Factors of x squared are, and the factors of 15 that we want to use are 3 and 5. Which one would be positive? I think you're jumping to the answer.
Oh, yeah.
Because we would need the 5 inside the factors to be negative, as x plus 3 times x minus 5 would be the correct factors. And because we do have two things multiplied together equal 0, one of them has to be 0. So either x plus 3 is equal to 0 or minus 5 is equal to 0. For x plus 3 to solve, we would subtract 3 from both sides, telling us x is equal to negative 3. Here we would add 5 to both sides, telling us x is equal to 5. Now at the beginning we said x cannot be 3 or 3. So the negative 3 does not work, telling us x is equal to 5. Any questions on any of this here? We good with this here? Yes? We'll stop here because I do know that there are several more in the note sheet. I don't think there's much more, because we have 3 left, and then there will be the last homework assignment. So you will get the last homework assignment tomorrow, and then we are done with chapter 7. Either way, because if we aren't in school tomorrow, I will still, because if that were to happen and we go virtual, they'll announce it most likely by the end of the day. I will have the video all set up, prepared to go. All you got to do is watch the video. I will give you the assignment then. And then there will be, for actual attendance and everything, because virtual we do have to take attendance still, I will put a quiz that essentially, if you watch the video, will give you the answer. So you have to answer that one question. Most likely it's just going to be solving this here. If I do 2 questions, it's going to be what are the restrictions and what's the solution for said problem, which will come straight from the video. And then I will post up the assignment. And if that's the case, you'll still have the makeup day Thursday, essentially Thursday, Friday if we do virtual both days. And I'll make up some quiz for y'all for Thursday, Friday if they are also virtual, which should be very, very easy. Get it right, you get the attendance for today. And then coming back on Monday, if we are virtual those days, Monday will be the review, Tuesday we'll go over it, Wednesday will be the test. Okay?